Great. Let's get started. Well, thank you all for being here today. Today we'll be speaking about feature stores. The actual title is as follows. But specifically, we're going to be going through a variety of things. Shab in chat to everyone, so to panelists and everyone. We'll post a link if she hasn't already to a notebook that we're going to go through later in this webinar, so you can follow along. Everything we'll talk about, every product-oriented thing we'll talk about is going to be based on Featureform, which is an open source feature store. It's on GitHub. Here's the QR code. We'll also include that in a link in the chat as well. Yeah. Actually, I'll post it in a moment. Or when we get I'll post it right now. Give me one moment. So by the way, at any point in time, if you have any questions, feel free to throw them in the Q&A. Great. So today we're going to talk about, so here, let me get this link for you all. The link is this one, and I will throw it in chat real quick. So let me stop sharing so I can do that. Real quick. Okay. Hosts and panelists, everyone. Okay. So yeah, so there is the collab, and then I'll post a GitHub link too. Awesome. And like I said, if you have any questions at any point, just feel free to throw it in the Q&A. Yeah, without further ado, let's keep going. So share my screen again. Great. So goal-wise today, we will be going through defining what a feature store is. We will talk about these different types of feature architectures, and we'll show how feature stores are used in practice. The way we're going to go through the actual agenda, we'll go through the feature engineering process, which I think a lot of people skip when they talk about feature stores. They talk about feature stores as like this kind of almost like production database thing, which is very different from how I see them used in reality. We'll talk about the goals of a feature store, the 3 types of architectures, how feature stores are actually used from single data scientists to large enterprise teams. And within that, we'll provide a demo for local mode feature form and hosted feature form. So presenters is myself. Mikiko is having Zoom issues, but she's here. But next time she'll lead the whole thing. So maybe I'll start with a bit about myself too. Before feature form, I built ML systems. I essentially ran a personalization service handling over 100 million monthly active users. We built all kinds of stuff in-house, and nowadays would be called MLOps. One thing in particular we called it our data platform. And that data platform has become kind of the foundation, or was one of the foundational pieces of our infrastructure there. Nowadays, that thing would definitely be called a feature store. And so a lot of the learnings and a lot of what feature form is from things I learned building kind of that data platform for personalization at scale. Cool. Well, let's jump into it. So let's start first with just, the term feature is really overloaded. So when I say feature, I just mean an input to a model. If you're Spotify, you're making music recommendations, you want to know the top artists that users listen to in the last month, that's a feature. Turns out that in reality, most ML systems have relatively generic models, and most of the time spent, in my experience, has been taking kind of my domain knowledge as a data scientist, crossing that with data, the data I have, and turning that into useful signal for my models. This is becoming more and more true, especially as things like Hugging Face rise to prominence. Like most models have become pretty commoditized, or you just like import scikit-learn and boom, like you have like the model you need. Sure, there might be some hyperparameter tuning, but in general, most of the time is spent on feature engineering. So when we built the data platform, the idea was, how do we make feature engineering faster, more reliable, more collaborative? And that those goals were kind of the foundational goals of the feature store. Because before, how we were doing things, we'd have our data scientists, they work in notebooks, they come up with ideas. They have a variety of notebooks, which are essentially just experiments, coming up with doing data analysis, just trying to figure out what could be a useful feature. Then they flip to a set of bash scripts or whatever to interact with Spark and Redis and whatever else infrastructure you're using to achieve a state where you could actually train your model and perhaps serve features to it in production, especially if it's like a online service. You need to have some sort of caching layer. So it's our job as data scientists to make all this happen. Like it's our job to interact with Spark, it's our job to interact with Redis, it's our job to interact with S3. With some companies, they separate it out. So there's two jobs. There's like the data scientist and like could be called a lot of different things, or an ML engineer, let's call it, where they would actually take the data scientist's notebook and then kind of make it in production. Regardless, there's a ton of it doesn't mesh well. And a lot of the point of the feature store is to give a framework so you can work on features. And as you're doing that, it will allow you to very easily get these things in production, version them, manage them, like avoid a lot of the issues that come up. So that experimentation process, that kind of the stuff that's happening in the notebook, is kind of defined by this flow. I know this is a lot of stuff. I'm going to break it down, I promise. But this whole flow is essentially the feature flow that everyone goes through. And I kind of like to break it down to two parts. The first part is what I would call kind of the feature engineering, where you find your data sources or get access to them somehow, which is a whole nother pain point. You prepare that data, you try to understand it, you analyze it, you a lot of what's happening in the notebook is this piece. You come up with kind of cleaner data sources, data sets that you can start to work on. And that's where feature engineering can come in, where you can really it's almost like the last mile transformations, where you really decide what features should I use, what features should exist, the final kind of feature transformations. And that in turn creates the features and the labels that you need to actually train your model. Once you have those, features aren't useful just in their existence, right? I mean, there's really two goals here. One is to serve them in production, and two is to train them. And even training with features is a whole process, right? You have your training set, you have your test set, you have your validation set or holdout set. And you kind of will use those to perform this whole process. So again, like as a data scientist, like you're kind of constantly going through this flow. And this is if everything goes really cleanly according to plan. But a lot of our time is actually spent kind of in this flow. And the point of a feature store or a virtual feature store, which I'll get into, is to provide the framework for the majority of, especially the left part of this map. Because what ends up happening in reality is that as we go through this flow, we create all this, like, it kind of looks like this, like UV2, don't touch, like random data sets, random like code that we copy and paste between notebooks. We end up with sending SQL to each other on Slack. All that, we call it the ops problem, like the communication being just ad hoc, the versioning management just all being ad hoc. Pretty much everything in this process essentially just being ad hoc. Like none of this exists beyond past our brain. Like we're kind of taking this in our head and we're applying it to these lower level abstractions. And so it ends up with a lot of waste, and it's very easy to kind of get into a place where things are unmanageable. Now let's talk about what a feature really is in production. So in production, a feature is made up of a set of real components. It starts with a data source, which could be a stream, a table, a file that we then transform. We store it for inference. Inference is kind of like what is the most current values of each of these features. So if I'm serving a recommendation right now, I can just get the feature values. And training, where I need to not only know the feature values today, but I need to know feature values historically. So if I have a label that is from 3 months ago, I can know what the values of my features would have been 3 months ago to train my data, my model rather, correctly. And all this stuff lives somewhere, right? Like this, all this is scattered across your infrastructure. Great. I'll take a second for, if anyone has any questions before I keep going, feel free to throw them in the Q&A. I'll take a look at that. Yeah, I'll just take a second, and we're gonna send slides after. So all the slides we will send. Cool. I'll wait a second if anyone has any questions. Just about before I jump into the next thing I'll jump into is the sets of problems we see when you're going through that flow, and the architectures of feature stores that we've seen to try to solve that. Great. Well, I'm not seeing any questions, so I'm going to keep going. But again, at any point in time, feel free to throw down some questions in chat, and I'll get to that. Great. So there's kind of two categories of problems that happen. We call them the ops problems and the platform problems. The ops problems are things like, how are these features defined? Am I allowed to use them? Who owns the feature? Which models are using this feature? Who built and who maintains this feature? And how do I use it in production? These are kind of the collaboration questions, the more the framework of features that's kind of missing. It kind of, again, it looks like this. And the platform piece is much more about how the feature is computed and stored, which is like, what's the feature's SLA? Like, what's the latency for serving? Is it streaming? Like, is it fresh? If it's an embedding, can I do a nearest neighbor lookup in the database it's stored in? These are platform problems. So there's two sets of problems. And so everything I talk about will kind of come with these two sets of problems. So there's three types of feature stores. There's three architectures. Most feature stores that exist today were originally created at so most feature stores that exist are either created internally, like they're just platforms that people built internally, or of all the vendors, pretty much all of them are based on architectures that were originally built at the big company. And all this happened kind of at the same time because we all had very similar problem spaces, statements rather. And we came up with, as a kind of ecosystem, there's three architectures that arose. We call them the literal, the physical, and the virtual. And just to give you a quick summary, the literal just literally stores features. So you create your features, then you store them in the feature store. There's the physical, where you create and store the features in the feature store. And then there's the virtual, which creates and stores the features as well, allows you to do that, but it runs like the actual compute and storage is on your infrastructure. So here's the literal feature store. This is really similar to how SageMaker looks, how Feast looks, how a lot of it's kind of that category of vendor looks. What we see here is without transformation support, it's still your job to run the features, create them in production, manage them, version them, share them. So all the platform problems that have to do with computing the feature, this doesn't solve. All the platform problems that have to do with, the ops problems of, hey, how is this feature defined? Who owns it? Where was it run? All those questions, like, can I use it? The majority of those questions cannot be solved because it's the feature transformation pipeline exists elsewhere. So this is the literal feature store. This is how most of the cloud services look like, and then the open source piece looks like this. Then there's what we call the physical feature store. With the physical feature store, it does do transformations, but it centralizes the framework of how you define features, but it also centralizes the infrastructure. It forces all the infrastructure to run in the feature store, and all the stores happen in the feature store. And what ends up happening in reality is, even though it kind of does a lot of it, it does it with high lock-in, and does it with forcing you to rewrite a lot of your features. So you're using today, let's say you're computing your features in Databricks, you're storing them in Cassandra, and maybe in Redis in some places. Like a physical feature store would force you to centralize all of that. So you'd essentially replace all that infrastructure and use the feature store vendor to do all that for you. Finally, we invented this idea. We call it the virtual feature store. The idea of the virtual feature store is, what would happen if you centralize the framework of defining features, but all the infrastructure that it actually runs on and is stored on, you own. So you can pick and choose the right infrastructure for your needs. So you essentially get feature form solving the ops problem. It's kind of doing the orchestration, the storage, all that stuff. And you have a variety of different vendors that we would work with that can do, our products that we could work with that would be your platform. Like if you're on Azure, Databricks, and Redis, if that's your stack, that's fine. Those pieces all work great for respective functions, but they aren't really feature stores, right? Like they need to work together a specific way to be a feature store. Like you need the abstraction of a feature, an abstraction of a training set. All that stuff doesn't exist natively in Databricks and Redis. But with feature form, we provide that. So that's all we do. We're kind of just the abstraction layer, the application layer of a feature store on top of your infrastructure. This is where the virtual feature store comes in. And the values there is there's low adoption cost because it's still running the same transformations you've been running on the same compute and storing in the same places. It's just we're kind of providing a framework. It's almost like Terraform. I mean, the name feature form comes from Terraform, to make it so adoption cost is low. The other piece of it is we let you choose the best-in-class compute for your platform needs. Like if you need a certain level of latency and you want to use Redis, you can do that. If you're trying to optimize, maybe latency isn't as important and you're optimizing for cost and you want to use something else to serve, like maybe you're serving out of Postgres or something, that's fine too. Like we don't really choose form. The virtual feature store doesn't optimize for the platform problem. It lets the end user solve that while just solving the operations problem, kind of providing the application layer of a feature store. So like with Redis, like we did a webinar with Redis a while back, and these are some things that they talked about where like Redis works really well for real time. But with feature form, it allows you to kind of take that data, compute it, it orchestrates it, puts it and materializes it in Redis. And it kind of adds that framework on top of Redis that you can use. So I'm going to jump into some code examples and usage patterns. But before I do that, again, I'd like to take a second, see if anyone has any questions. Feel free to throw them in Q&A. I'll check in a moment again because I don't see any right now. And then people on our team should be checking the LinkedIn and Twitter and wherever else we're streaming. So if you have any questions there, we can also get to them. So like I said, like with the virtual feature store, our goal is to be the framework so that all this stuff, rather than it living in your head, becomes inherently part of the framework. And that can be useful from whether you're a single data scientist working locally, all the way up to an organization or enterprise. And I'll explain how. So first, let's talk about a single data scientist working locally, right? They're still doing this, all the stuff we talked about. They have maybe a CSV on their laptop. They are iterating on it. They're coming up with transformations. They're coming up with features. They're training models on it. And in this world, the feature store acts like a repository of features, just so that it's a framework, so that when you're creating all these resources, you use the framework and it automatically kind of stores in one place. So you're not copying and pasting code. Versioning is inherently part of the framework. Managing and organizing all your stuff, it's just inherently part of how the framework works. And so it becomes that repository. It keeps a history of changes, and it's just good form. Because if you're adding more people to your team, if you're starting to put things in production, all that stuff is way easier if you're already using feature form. So first thing I'll do is show a demo of that. We put in chat the link if that you can use to go and see the same notebook. So let's start by walking through the notebook. Great. So cool. So first thing we're gonna do is pip install feature form. I've already run this. It takes a bit, but like I said, feature form is open source. It's you can just pip install it and use it locally, and obviously you can also deploy it and use it in a hosted way, which we'll show later. Yeah, for the time being, let's just walk through it in this way. So first thing we're going to do is we have this this data set rather. It's transactions data set. It's in we have it in oh fun, it's got disconnected. One sec. Yeah, so let's first pip install feature form. Great, my runtime's initializing, which I tried to get this all set up before. So one moment. And again, you can run this yourself, so you can kind of follow along. I'm gonna try this again and see if I can get it to here, I'm gonna just delete this runtime and see if I can run that again, just because it's taking a second. Okay, here, I'm gonna reconnect. And yeah, hopefully you guys are following along. The link should be in the Zoom chat. Cool. So yeah, first thing we're gonna do, we're gonna install feature form. Again, so it's a pip library, or a PyPy library rather, that you can use if you're just working locally. If you're working in a hosted management, if you have infrastructure, etc., then you're gonna want to deploy it. The deployment's pretty simple. You can just deploy it in Kubernetes. It's a Helm install. But for this example, I'm going to show one example of it with a more complicated setup, and then this example is truly just local mode. So you don't need to do anything. The only dependency is pip install feature form. Cool. So it's going to take a moment. Once it's installed, we're going to download this data set. The data set looks like this. It's a CSV. It has like transaction ID, customer ID, transaction amount, just a variety of things. And the goal, there's a label column, which is this fraud? And so our goal in this example is to build a training set and features that we can serve for if a transaction is fraudulent. So I'm gonna run this next. Once this is done, this will oh cool, that worked out timing wise. Yeah, so I just downloaded the CSV. First thing I need to do, I'm gonna import local from feature form. That's just local mode. It looks very similar again to hosted mode or to managed mode, but it just only the compute, it's virtual, right? So the compute and the storage is up to you. If you use local mode, then we'll use your laptop as compute and storage. And so we're going to register that file we downloaded, transactions.csv. And we can actually convert all these resources in local mode to pandas. If we ever want to just like do something that requires straight up pandas, we can always just convert back and forth between the two. So you can kind of continue doing workflows as you would as a data scientist. So we'll do that next. We're registering the file here. After the file is registered, we are going to, my runtime disconnected again. Okay. Yeah, sorry guys, my internet is being a little bit weird. Okay, next thing I'm gonna do is I'm just gonna, again, it's just a CSV, so you can just kind of plot things. And like I said, at any point, if you have any questions, feel free to ask. I saw some questions or a question pop up, so I'll quickly look at that. So question, what do you mean by register as transactions.csv file? Great question. So the registering something with feature form just means that feature form is aware of it. So you can give it, in this case, we're only giving it a description. You can give it a version. You can give it like metadata. We're going to show the dashboard later, but it kind of becomes something that you can view in a dashboard. You can reuse it in other places. So rather than having to remember where this file path is, you just remember the name of this resource you created called transactions. So that's what registering it means. But great question. Cool. So let's keep going. We can actually create transformations to see yeah, we create transformations on top of our transformations. We can kind of chain them together. We can create a DAG. So this is a transformation that actually uses the other transformations input. This transformation is taking the average amount per user. We notice when we plot this that, hey, this is like pretty skewed. So we're going to just cut everything that's 2 standard deviations above the mean. So we're kind of clipping it. So we can create this as a transformation. We can plot it again. We can see that this looks a little better, and maybe this is good enough for our use case, or maybe this is the right thing for our use case. Then I don't want to do. So going back to like the idea of here, what we've done so far is we've done some data cleaning. We've done some data transformation. We've done some analysis. We've kind of gone through this. We have some data sets that we think are solid to use for features. So next thing we're going to do is actually create the features. And my internet keeps cutting out, so I'm going to not be able to run these things, but you could run these things locally. So first thing I'm going to do is register an entity. When I register the entity is kind of like a primary key. Let's see if this works. The primary key just allows it so that you can associate features and labels and other things to this entity. So the user entity just means that I can create features and I can associate them with user. Then I take some of those transformations, those I created before, those sources, and I can say that column transaction amount is actually a feature called average transactions, and it's associated with user entity. I put the inference story equals locally here. This is the place where if you were running in Redis or you want this in Dynamo, you could do that. Here, everything's just local. And then I can take that column from the original file is fraud and register it as a label and also associate with that entity. So I'll run that. Then I can register my training set. My training set in this case is very simple. It's called fraud training. There's one label, fraudulent, which I defined up here, and there's one feature, average transactions. So I'll do that. Great. So now I have I've defined everything. I've done, again, like going through here, I've done the data preparation. I've created my data sets. I've created feature engineering. I've kind of gone through this. I created features and labels. I've created and defined my training set. In this example, we're not doing tests, holdout set, but you could do that as well. And now I'm going to train my model, and then I'm going to serve to this trained model in production. So how I do that. So by the way, I have to apply it. Applying it just saves it to that repository I talked about. So feature form now has all this metadata. If this was hosted, it would orchestrate your infrastructure. In this case, it's actually running all this stuff on your laptop or in this notebook to create all these things for you. You know, there's a UI you could check out. I'll go deeper into it where you could really see this stuff, understand it, you know, dig through it. Then when I want to serve, I can just say, hey, I want that training set that I defined earlier. You can repeat it, shuffle it, batch it, whatever you need to do for your specific training motion. And see if this works. My internet kept cutting out, so it might not, but we'll see. Yeah, so you have this training set now. We can use it to train a model. And the training is really simple. Like we created these batches of 12. We're going to loop through each of these batches. We're going to partial fit a classifier. It's just a standard gradient descent classifier where we pulled from learn. And yeah, we're just going to train our model. Once the model is trained, we can also make predictions on specific users. So, hey, we have this average transaction for user, you know, C465, whatever. And we can get those features, and then we can make a prediction on those features using the trained model. Great. So again, if you have any questions, feel free to throw them in chat, and I will get them. I see one question I'll quickly look at. In non-local mode, is there an API server to support multiple users? Yeah, so I'll show that right after. I'll show how it looks like in like non-local mode. But yes, we do. So governance, users, access control, all that stuff is not in the open source. That's in our enterprise version, which is essentially our paid product. But yeah, there's like an API server of it, so you can I guess in short, feature policies like governance, access control, like some things like when new features are created, run them in a dev cluster. That doesn't exist in open source. It only exists in the kind of, that's our product that we sell, but everything else exists in open source. So you can see here, we trained the model and we made a prediction. Now let's quickly look at like how this would look like in a more complex version. So in this version, we have I have an EMR cluster running in AWS. I have DynamoDB running, also in AWS. I have way more files. They're Parquet files in S3. And so I register them all. I have you know, more complex SQL queries. Mikiko wrote these, she loves SQL. I'm more of a data frame person. And for me, like I might write them more like this. So you can also use data frames. We support both SQL and data frames. You know, you can do all kinds of stuff, can get more complicated. But everything else looks very similar. I mean, even the transformations are very specific to like where you're running. Like this is like SQL code that runs on Spark. But you know, the entities registering the features is very similar. And the labels is similar, registering the training sets. We're creating 2 of them here. It's very similar. When you apply them, there's more things getting applied. This will actually orchestrate the infrastructure. So this will run it in Spark. You can set up a schedule. You can do all kinds of stuff here. And yeah, training. Training looks very similar. Like you can get that training set, same thing. You can loop through it. You can train your model. And then yeah, serving features is similar. And you know, you get this UI. This UI is for the actual hosted one, so there's more stuff in it. You can look at feature. You can see how it was defined. In this case, it's running in Spark. It's this SQL is what created it. You can do things like look at an entity like customer, and you can understand, what features do I have that are associated with a customer. Great. I'll take a pause here. If there's any questions that are open, feel free to ask them. Yeah. So, by the way, Super, the one question you asked about what values go into the online store, typically with things that have time series, you want the most recent values of features to be in the online store. And so that's kind of it's almost like a cache, so that you could really quickly serve features. Whereas for training, you need kind of old values of features. Great. Two open questions. Can you explain how to upsert features in feature form, and what are different sources? I showed the CSV. So can I explain the upsert features to feature form? Yeah, so we automatically do that for you. You're defining the transformations. We'll run those transformations. We'll update the inference store and the training store for you automatically. So you as a data scientist, you're essentially telling us your desired state. I have this feature. It's defined by this set of transformations. It's this column associated to this entity. And once you do all that for us, like you kind of give us that metadata, we'll actually go run it for you. And then with regards to the different sources, there's more in the docs here. Like I showed Parquet files, we support tables, streams, etc. We support, but I don't know off the top of my head exactly which ones we support. But I know typically we find ourselves using Parquet and CSV. So if you need something else, definitely jump into our Slack channel. Feel free to ask more. Ask for more, rather. Great. Let me talk about maybe more complex use cases. So we talked a bit about, there's one more question. Let me make sure I get to that. Or maybe there isn't. Cool. So, if you have things in production, sorry. There's a question. I think it was asked on LinkedIn. Shab just sharing with me. Does the UI exist in open source? Yes, it does. If you're running locally, we have this thing. It's the command line tool. You can write feature form dash. And so if I can go to our docs. Again, all this is open source. If you go to docs.featureform.com, you can go to, I think it's quick start local. And if you scroll to, it doesn't show it here, but there's this thing called feature form dash. When you call feature form dash, it will actually open up in your browser, it'll open up localhost 3000. So yeah, the UI exists even in open source. However, both in the managed and in the local version, it exists. Cool. Let me talk a bit about when you have things in production, you want to simplify feature deployment, you want to monitor features, you want to unify the experimentation and production. Rather than treating the feature store as where features go once they're in production, we really view it as a framework across both. And so this is where it becomes valuable if you're a single person. If you get to the team level, then all of a sudden you're worried about sharing things, you're worried about communication, collaboration, you're worried about onboarding new people, having new people be able to see discover and understand each other's work, and to, again, reuse things and share them safely because things are immutable. Finally, for the enterprise, we get, there's a variety of things that begin to happen here. Like there are feature policies, like certain features can't be served in Europe, or features have to go through the dev cluster, and it has to, hit these sorts of KPIs before we can put them in prod. All that logic, like we call feature policies. All that exists. It's an enterprise version of feature form, but you start to get like how structure. Like you have certain teams using Redis, certain teams using Cassandra, certain teams using a vector database, etc. All that stuff can exist under the same abstraction layer, under the same application layer, which is feature form. Governance, access control, audit logs, and cross-functional workflows, like things so that DevOps people, so regulators, so legal, so everyone can kind of put in the business logic that needs to exist in the feature store, and the feature store will enforce the policies. Like I said, it's all open source. So if you Google feature form or feature form GitHub, it will show up. There's a QR code for those who are into QR codes. And you can find me on LinkedIn. And I'll leave some time. I'm leaving some time at the end if anyone has any final questions for me or anyone on the team. Yeah, feel free to ask if you have any questions. I see a question that was asked a little bit earlier, which is what about data in structured relational formats like on-prem databases like Oracle and Teradata? Can we run those in local mode to move the data onto its current platform? So if you're working in Teradata, let's say, you would have to use the managed version, and then we could connect to it. We don't currently support sampling in local mode from production databases, though that is something that we're working on. So that should happen soon, but it doesn't exist today in local mode. But it's very much on our roadmap. It's actually a core thing that we're trying to build. I see another question. Can you talk about how enterprises can govern the feature store? Yeah. So there's a few. So pretty much how it works is we have these ideas of hooks. They're Python functions that you can register a feature form for different things that can happen. Like this Python function runs when a feature is created. And you can use it to update the resource. You can use it to update the provider so it runs somewhere else. You can do it so that, hey, like if a thing happens, it fails. At serving time, we also allow you to hook in functions so that you can do things like say, hey, this isn't allowed to be served to this model. All that logic is just Python code that you can register into different hook places into the feature store. And that's kind of how it ends up working. A great question. And then the actual that's more the governance features. If you're talking about like hosting and managing, we run in Kubernetes locally, so you could just run in Kubernetes natively, rather. And so you can Helm install feature form and just start using it. So yeah, so Kubernetes and also yeah, we have. I mean, obviously we can also like manage and support it. And most of our enterprise deployments like are on-prem or in your cloud, and so we still manage it, make sure it stays up, do all the updates, do all that stuff, but it runs in your. It's not, the data never leaves your system. How do you encourage people to use features in feature stores, get them to contribute back? Yeah, this is a great question. What we see happen in reality is because the framework is inherently part of the code base. If you're using that code base, it's almost like if you're using a Ruby on Rails, if you're working on a Ruby on Rails project, but you like using Go or Python, it sucks. You're still using Ruby on Rails. I mean, that's just how the framework is. So what we see a lot is people start using feature form. It becomes a key piece of how they serve features to the model. So if you want to add new features, you have to add them to feature form. Well, new resources that are created in feature form are automatically centralized. Again, like we have visibility levels and other things in enterprise, so it doesn't have to like clog up the global namespace. But in general, just like naturally you start using the framework, and that means you're naturally kind of contributing back to the feature source so that other people can reuse your features or at least see how they're defined and be more productive. So it just kind of happens automatically. In terms of using the features, if you want to use features in feature form that they're defined in feature form, you have to use the feature form library. So again, it's the same thing. It's more like if you're using feature form, you don't have to use feature form everywhere, but typically it's just easier to use feature form to serve all the features rather than have half in feature form, half out of feature form. Something that we see that half in, half out as people are moving things over. Part of the virtual approach is that it's low cost, low adoption, low friction. So you can start moving things over incrementally, and that's totally fine. And we see that too. What language is feature form written in? So feature form is primarily written in Go. Obviously, there's a lot of Python involved too, just because the library is Python, the client's Python. We run some PySpark code, we run Python code, we support like native Kubernetes functions. So we do have some Python. I think it's like 90% of the code base is Go, not more. So it's mostly Go. And some React on the front end. Great, these are good questions. And so after this, we're going to send out the slides. We'll send out the local notebook again for those who maybe want to play around a bit later. And at any point, if you have any questions, we have a Slack community you can join. We'll send that afterwards. We try to do webinars every few weeks. So the next one probably won't happen until January. So this is actually the last one of the year. So congratulations thanks for being here. Yeah, thank you all. If there's a question, I'll be on for another minute, but otherwise it was great answering your questions. And if anyone needs anything, where to find me, feel free to reach out. Also, I'm at simba@featureform.com. Feel free to send me emails; those really go to me, and I try to read them, especially if they're questions. Awesome. I see one more question. Do you have a plugin-based architecture so we can expand data store? Yeah, we do. We have a plugin-based infrastructure so you can create your own online stores and offline stores. It's honestly not the best documented in our docs. So if you're planning to do that, join our Slack and we can help you. But great. Yeah. That's how we do it. So we do have like a nice interface. Great. And Shab, you were saying something?
Yeah, I just sent you 3 more questions.
Oh, we have some more questions. My bad. Okay. Okay. Are we moving the data after the feature engineering is performed, or can it be stored locally? So are we moving the data after feature engineering is performed, or it can be stored locally? So if you're using local mode, then yeah, it's local. If you're hosting in Kubernetes, we try to keep the data in the data source, like where they are. So if you're running data, it's an S3, you're using Spark, like we don't put it in feature form. Like it goes directly between S3 and Spark and Redis. Well, the Spark to Redis we have to do for Kubernetes, but that's just because there's no other way to do it. But yeah, we try not to pull data into us. We try to be pretty low footprint in the cluster. And then, yeah, governance on the data store problem, it's a big piece of our enterprise product. So we do handle that quite a bit. And then what's the infrastructure requirements for optimal performance? Well, it's a great question because optimal performance depends on your use case, right? Like optimal performance could be it needs to run as fast as possible. Maybe you want like in-memory Redis. That's fine. We support that. Maybe optimal performance is it's really cheap, in which case maybe you want something else. And we support that as well. Whatever you're doing. Like if you want to use Postgres or Snowflake as an online store because you don't care about latency, you just care about cost, that's something we handle. And then I think that is all on the question side that I see, and LinkedIn as well. But again, thank you all for the great questions. And then let's make sure there's no other ones. Yeah, thank you. All right.